Hey guys, BrandonioProductions here, and welcome to How to Create Your Own Platforming Game in Java Part 3. Now first of all, I apologize for the wait time for this tutorial. I've been very busy, and when I was thinking about the actual tutorial of how to make a platformer, there are several things that I'm going to use in this tutorial that I have not actually taught formally in other tutorials. So I wanted to make sure that you guys actually had knowledge of how to use these other things before we actually implement them into our platforming game. So what you're looking at here is our current platform game. Currently, if we actually run the project here, you can see that what we have is a window that moves a rectangle across the screen, and it moves fairly smoothly, so we're all good there. So what we're currently building is actually the level editor. So essentially, what we want to do in our level editor is we actually want to be able to place blocks wherever the user desires. And that is going to be done by clicking. So we've already set up that each block is going to be 25 by 25 pixels. So that's really all the knowledge we need. So let's go ahead and dive right into the tutorial. So the first thing we're going to need is we're going to actually need to add the ability for the user to click inside of our actual level editor. So in order to do that, we're going to make our level editor here. We don't need to type implements again. We're going to need our level editor here to implement the mouselistener class. So the mouselistener class is the class that allows you to actually detect mouse clicks within an application. So what I did there is I just imported the mouselistener class, and now I'm going to let Eclipse add the unimplemented methods. And then we're going to scroll all the way down and grab the two methods that we need, or actually just the one, called mouseClicked. And then we're going to bring it up to the top so we can stay a little bit organized. So, since all we really want to do here is go ahead and add the ability to click, and when you click, you want to add the ability to actually, or you want a block to actually appear on the screen, this should be fairly easy. So before we actually get started coding the click code, we need to make sure that we actually specify to our applet that it's its own mouse listener. So we can do that by typing in this.add mouse listener and setting this as a parameter in the initiation there, or initialization, constructor, whatever you want to call it. So now our applet actually knows that it's its own mouse listener. So now we can go ahead and scroll back down to mouse clicked. Now when the mouse is clicked, what we want to do is we actually kind of want to snap the blocks into where they should go. Since each block is 25 by 25 pixels long, we only want each block to occur every 25, or one block to occur every 25 pixels. So it's going to snap it into the nearest 25 pixels. Now this requires a little bit of algebra, so I'm sorry if this confuses you, but I'm just going to go ahead and get started. So the first thing we need to do is save the x coordinate of the mouse. So we can do that with int mouse x equal to e.getx, and then we can say int mouse y equal to e.gety. So now what we need to do is we actually need to generate our locations. So since the mouse is actually being pressed anywhere on the screen, the first thing we need to do is we need to divide that mouse by 25 to get how many 25s, like how many blocks over it is. So now we can say mouse x divide equal 25. Well, we can also just do this in one big thing. So mouse x equals mouse x times 25, or divided by 25 is what I said. And then after we divide it by 25, which is essentially going to eliminate any remainder of 25, then we can multiply 25 back into it. So, for example, if the user clicks on a square 120, what it's going to do is it's going to go ahead and divide 120 by 25, giving a number of 4 because it is integer division. And then we're going to multiply 4 by 25 once again to get 100. So when the user clicks on 120, they're actually going to be putting a block in the 100 coordinate square. So we're going to do the same thing for y here. If I can type, equals mouse, oh my gosh, y divided by 25 times 25. And now we've actually got our on-screen x and y coordinates. Yes. So as we recall, what we actually set up here is in order to hold our blocks on the grid, we actually set up a double array. The left Oh, I see how we set it up. Okay, so the double array. So there's going to be 50 slots in the x-coordinate and 50 slots in the y-coordinate. Now, one thing that we did do that we didn't really counter for is we only put 50 blocks. So we're going to have 50 blocks going to the right and 50 blocks going down. Now, in order to actually hold those locations properly in the array, we're actually going to delete this times 25 line. So what we're going to do is we're just going to get how many blocks over the block needs to be placed, and then we're going to place it in the array there. So now all we need to do is, since if we open up our little project outline here, we can see that our grid variable is a double array of objects. So we're just going to say grid mouse x mouse y equals. And now since we click, we need to actually specify a new block. So we're going to say new block, and this is an object that we actually created. Now the block class, what we actually set up for is the block object itself is going to contain the actual x and the actual y of the object. So inside of the block class here, we're actually just going to send in mouse x times 25 and mouse y times 25. So now we have actually set up our grid system. So we store this new block in the grid wherever the user clicks, and that's that. However, if we actually run the program, you can see that if we click anywhere, nothing happens. Well, this is because we actually need to make our program draw the blocks. So in a previous tutorial, we set up the run logic of this actual program. So what we're doing in our run logic is, first of all, we're calculating everything that needs to happen. And then we're drawing everything on the back buffer, and then we're drawing the buffer to the screen. So what we need to worry about is our draw method here, which can be found down here. So all we need to do is set up our drawing our blocks here. So we've already got a graphics 2D object that we can go ahead and utilize. But now all we need to do is we need to scroll through our grid object and draw everything. So we can do this by putting a for statement inside of a for statement. So we're just going to say for int x equal to 0, x is less than grid dot length, and x plus plus. And then inside of this for statement, we're going to scroll through the y values and say for int y equal to 0, y is less than grid dot, or actually this is grid x dot length, and y plus plus. So why did we put this grid x dot length here? Well, this is because we are using a double array, and a double array contains two objects with a length: the first array and the second array. The first array can be accessed by just typing in grid dot length. However, the second array must be like an object of the first array. So we're sending in an index of x, and we're getting the length of that array, which is indeed our second array. I know it's kind of confusing. However, if you simply type grid.length, that will only give you the length of the first dimension in our two-dimensional array. So now that we're effectively scrolling through our grid, we're just going to go ahead and draw all of the boxes that we have in our grid onto the screen. So we're going to first create a new block. The first thing we need to do is check to see if the object that we found is an instance of a block object. And this can be done using the instance of command. So we're going to say if, first we're going to save the object. Object O is grid x, y. So we're just getting the grid object at the location of x, y. And then we're saying if O is instance of block, which is a previously set up class, then all we're going to want to do is we're going to want to draw the block onto the screen. So the first thing we're going to do is we're going to convert O to a block by saying block to draw. So we're creating a block variable equals to block O. So all we're doing is casting the O to a block object, and then we're just saying block to draw dot draw. And we're going to go ahead and send in our graphics object, which is going to be called buffer graphics, because it does not need a graphics 2D object, just a graphics. So we can go ahead and delete this graphics 2D line. So now what we need to do is actually make sure that everything is still set up okay. Now, do logic, currently we do not actually need anything to do logic inside of the level editor, so we're just going to delete that line. And we're also going to delete the rectangle called rect, because that was for another purpose. So now we can go ahead and test out our application. If we go ahead and run the level editor here, if we click somewhere, nothing happens, which of course tends to happen when I do a tutorial. I must have missed something somewhere. So as you can see, nothing happens when we click. Let's try to figure out why here. So let's go ahead and delve into our block class to make sure the draw method is set up properly. See, what we have here is we have the g.fillRect of this.x times 25 and this.y times 25. So what we actually accounted for in our level editor class was already accounted for within the block class. So all we have to do when we create our new block is eliminate this times 25 and this other times 25, because the block class already takes care of that for us. So we're just going to go ahead and run level editor window once again. And as you can see now, when we click, we get our boxes. So we can go ahead and design a level like this. So as you can see, it actually snaps. So if I want to draw a block somewhat over this one, I cannot. I have to go over to the 25 by 25 pixel square above it. So this creates a nice uniform area where you can actually design a level. So now the next question to actually ask is, how do we add multiple blocks to our level editor? Sure, you may want to just design a whole level with one type of block, which would be, of course, the default land block. However, don't you also want something like ladders or enemies or spikes that can kill the player? Of course you do. So let's go ahead and set up that right now. So the first thing we need to do is we actually need to create a variable. No, wait. No. We're not going to do that just yet. The first thing we need to do is we're actually going to create another block object. So inside of our level editor package here, we're going to go ahead and create a new class, and we're just going to name this class called spikes, because, yes, spikes. We want to kill the object, or not the object, the player. And then the super class, we're just going to leave all this as it is so we can go ahead and code it in the class. So since spikes are a type of block, we're going to make them extends our block class. Now when we actually type in extends block, we can choose to override some of the methods. So in order to actually override or see which methods we can override, we can go ahead and right click in Eclipse, go to source, and then go to override / implement methods. And then we have all the methods of the block class that we can actually override. So the first thing that we actually want to override is the draw method, because instead of drawing a rectangle onto the screen, we actually want to draw the spikes image onto the screen. And that's really all we need to override. So let's go ahead and set up our constructor as well. So we're going to set up our default constructor, which is going to be public block, and that's just going to call, or public spikes rather, and this is just going to call the block superclass, or super constructor. The superclass is constructor, sorry. And then we're going to go ahead and type in the other constructor, so public spikes, and let's go ahead and refer back to our block class. So we need an integer of an x and an integer of a y for its position. So this is going to take an int x, int y, and then we're just going to go super xy. So we have effectively created our own different block besides the default block. So the next thing we need to do is we actually need to create an image for this block in particular. So let's go ahead and open up the highly advanced Microsoft Paint, and we're going to go into properties here, and make sure that our picture is actually set up in 25 by 25 pixels, which it is. And then we're going to zoom in a lot so we can get a nice detailed picture going. And we're just going to go ahead and draw some spikes. So let's just... That is too thick. So just design some little spikes here. Okay, and one thing that you actually want to make sure of is you actually want to make sure that the spikes reach the top of the image, and I am definitely not doing that. So you know what? I am just going to start over. Because when we actually detect collisions, we're going to be detecting collisions with the image, and that is 25 by 25. So we want to make sure that if the player hits the top of the image, they're actually hitting the top of the spikes. So these are not the best spikes in the world, but whatever. Then we're just going to go ahead and give our spikes a nice gray color here. Okay, so now we have a basic spike image. So now what we're going to do is we're actually going to save our spike image by clicking Save As, and then we're going to navigate to where our project is saved to. So I have mine saved in Java Workspace 2, Tutorial Game, and then there are a couple of folders that you actually need to dive into. So what we're going to do is we're actually going to put this image in multiple places. Because one thing about Eclipse is when you actually import a project from a different location, it will clean the folder, or the folder with the important information in it, so you will actually lose your images if you import it into a different version of Eclipse. So I'm going to go ahead and save the images outside of the bin folder in a new folder called Images, and I'm just going to call this one spikes.png. So now that we've got our new image set up, we can go ahead and browse to wherever the project is saved. And then we're just going to copy this images folder into the bin directory, and just because we can, we'll also put it in the level editor directory. So now we can now that we have an actual image, we can set up the image within the spikes class. So if we look back at the block class here, the block has a private variable storing the image, and it actually has a variable to get an image that so it has the to get any image inside of the file system. So all we need to do now is actually set up the image for our spikes. So in the constructor, we are going to actually say this dot set image, or set block image, and then we need to get an image. So we're going to say this dot get image, and it wants to send in a path, and our path is images/spikes.png. So that is actually this right here will actually set up the image properly and define it with the private variable inside the block class. And now we just need to redefine our draw class. So in the draw class, all we need to say is g.drawImage, and then we're going to say this.getBlockImage, and then it needs the x, y, width, and height variables. So for the x, we're going to say this.getX, and remember we need to multiply it by 25, this.getY times 25. And then we need to specify width and height, so we're just going to say 25 by 25, of course, and that should be good. Maybe. Whoa. I think we actually need to pop on a null at the end of that. There we go. So now our image will actually be drawn when the block is placed on the screen. So let's go ahead and test out this spikes block by referring back to our level editor class. And when we actually click on the screen, instead of creating a new block, we're going to create a new spikes. And that should do that. So we're just going to run the application here. And now if we click on the screen, instead of getting a nice block, we get these really ugly spikes. Wow, those are terribly drawn. Okay, so now that we have multiple blocks set up, and we know that our code works to support these multiple types of blocks, how do we switch in between the blocks? Well, it is fairly simple. The first thing we need to do is actually create a private integer variable to keep track of what index of block we are on. So we can do that by just simply typing in private int selected block, and by default we're going to have 0 selected. Now what we're going to do is we're actually going to create a static class that keeps track of blocks and their respected indices. Well, actually we're not going to do that. We're just going to pop this into the block class, which is a fairly poor style, but we're going to do it anyway. So inside of the block class, we're just going to create a new method right on top here called public static, and it's going to be called getBlock. And what we want to send in is a block index, let's just say, sorry, a location, and yes, an X location and a Y location. So what this actual, and it needs to return a block. So this method we're actually going to use to return any sort of block that is specified by the level editor. So as we saw, we have a new variable that keeps track of the selected block, and that selected block index will actually allow us to return a block. So we're going to use a switch statement here and say switch block index. So if block index is 0, then we're going to return a new block of the coordinates x and y. Then we are going to break. However, if the case is 1, we can return a new spikes of the location x, y, and then go ahead and break out of this switch statement. And then, of course, we want the default case where we just break. Right? I mean that. Oh, okay. Since we're actually returning within each case, we don't actually need the break statements to end off the cases. And in our default statement, instead of actually returning nothing, we're simply going to return the default block if they specify a number, which is not going to happen. But if it happens by chance, we're just going to go ahead and return the normal block. So what we're doing in this method here is we're simply going to hand over the block index and the location of the block, and that will give us a new instance of the block class or the spikes class, a new instance of the specified block. So now we can go ahead and minimize this method since we're done with it, and go ahead and go right back to our level editor class. So now we have a integer selected block, and it's equal to 0 that we're going to have to deal with. Now what we want to do is every time the user presses a right arrow key on their keyboard, we want to increment the selected block variable by 1. But when they press the left arrow key on the keyboard, we want to decrement the selected block variable by 1 until it reaches its maximum potential or maximum value. So we're just going to go ahead and find our key pressed method and change this event handler to e. And so we're just going to say if e.getKey code equals key event.vk right. So we need to, the right arrow key was pressed. We need to increment counter by 1. So now we're just going to say selected block plus plus. However, since selected block has a maximum value of 1, because as you see, the method that we set up in the block class, it only has handlers for when the case is 0 or when the case is 1. So selected block can only be 0 or 1 at this point in time. So we're just going to say if selected block is less than 1, then we can increment selected block. However, if the user actually presses the left arrow key, we want to decrement the counter by 1. So we're going to say if selected block is greater than 0, because that's the minimum value of it, we're going to say selected block minus minus, which actually decrements it by 1. So now the last thing we need to edit is when the mouse is clicked, instead of actually creating a new spikes or a new specific type of block, we're just going to go ahead and access the general statement, the general static statement that we created in the block class. So we can say block.get block, and the block index is going to be selected block, our private variable, and x is going to be mouse x, and y is going to be mouse y. So now we can go ahead and end that statement, and now we should be able to switch blocks. So let's go ahead and run the application. And if we click, as you can see, by default, we start getting our basic block, and we can go ahead and create a level with this. So we've got a basic platform where the player can go. However, it drops off right here, and there are going to be spikes. So just as we may have wanted, if we press the right arrow key on the keyboard, it actually selects the index of the spikes, and then we can go ahead and press the select, or the left arrow key on the keyboard, and it switches back to the index of the blocks. So we now effectively have a multi-block system whereby the user or whoever is creating the level can actually select multiple blocks. Of course, there is no indicator of what block you currently have selected, but that's okay. We can go ahead and make an indicator now. So all we need to do to make an indicator, let's just say we're going to make an indicator at the mouse's location. Well, do we want to do that? Yeah, let's do that. So in order to actually make an indicator on the mouse's location, we're actually going to want to keep track of the mouse's location. So we can say private int mouse x and private int mouse y. And then in our constructor, we can just set those to 0, 0. So we're going to say mouse x equals 0 and mouse y equals 0. So now every time that the mouse moves, which we already have, or we don't already have that set up, so we're just going to add a mouse motion listener onto this, mouse motion listener, which will track every time the mouse moves. Wait a second. Yeah. Okay. So every time the mouse moves, we actually need to update these variables that keep track of the x and y position of the mouse. So we're going to go ahead and take this mouse moved method and move it up to the top since we're going to be using it. Delete the auto-generated method stub. And let's go ahead and put in some code. So we're just going to say this.mousex equals e.getx, and this.mousey equals e.getY. So now, finally, what we want to do is on the draw method, we want to simply update it. So not only does it draw the blocks that are on the screen, but it also draws a block on the essentially on the user's cursor. So after the for statement, where we draw all the blocks onto the screen, we're just going to say block dot get block, and then we want to say selected block, and we want it to draw at mouse x, mouse y, and we're just going to say draw and send in G. So what we're doing here is we're accessing a oh, it's not called G, it's called buffer graphics. My bad. So what we're doing here is we're just accessing a new block that is being returned since we set in selected block, and we're just drawing it on top of the cursor. So let's go ahead and run our application, and as you can see, oh, I did it again. I do this in all my tutorials. We forgot to say this.add mouse motion listener this. So we forgot to effectively alert the applet that it is its own mouse motion listener. So now if we go ahead and move our mouse around, it oh my. Okay. Okay. What we actually forgot to do is when the mouse is moved, we forgot to divide the value by 25. So the block on our mouse's cursor will actually snap as well. So as you can see, now that we actually have the correct values set up, we have this block that kind of follows our mouse around. And if we press the right arrow key, yeah, there we go. If we press the right arrow key, it actually switches the block from spikes to the default block. So with this system, we can effectively design a really basic level. So thanks for watching this tutorial on how to create a Java platformer, part 3 actually. In this part we went over how to add your mouse motion listener, detect clicks, and we actually went ahead and added a new block besides the default block. In the next tutorial we will be working on the player class and creating blocks that interact with the player. So thanks for watching this tutorial. Please remember to rate, comment, subscribe, and stay tuned for the next version. Peace.